Later nights on December 18th, 22-23, the East Atlantic cities of Guadalajara expressed the worst nightmare. After the earthquake filled suspense, a volcano's fissures opened 4 kilometers northeast and began spewing lava fountains and 100 meters tall. Luckily, the modern road flow elsewhere narrowly avoiding a small fishing town. But Iceland wasn't willing to leave Grindavík's fate to change again. To prepare for the future eruption, the government began exploring how to control this hard river of destruction. Studying lava flow is about as difficult as it sounds. Molten rock which we call magma when it's underground, and lava when it's break through the Earth's surface can reach temperatures of roughly 1,200 Celsius. That's over 4 times hotter than the maximum temperature in a suffocation oven. Now imagine that heat radiating from several square kilometers. At this temperature, lava emits melt, melting in its path. And since it's as heavy and distant on the rock and is composed to flow, it's almost unstoppable. Fortunately, there are 2 factors that make lava flows a little easier to handle. First, while it can take decades to cool completely, lava becomes solid still after cooling to roughly 600 Celsius. This process typically happens on its own in just a few hours, unless an ongoing erosion is failing. Second, lava generally flow at a rate of less than 1 km per hour. This slow speed gives people time to evacuate and respond with various solutions, though some ideas are better than others. One questionable chairman of the first director of the Hawaii Volcano Observatory, Thomas Geiger, was to fight lava with bombs. When the 1835 eruption of Mauna Loa threatened the Hawaiian town of Hilo, he convinced the U.S. Army aircraft to drop 12 bombs to depress this part and stop its lap and fast. 6 days after the operation, the lava did stop flowing, prompting Geiger and the U.S. Air Force to label the mission a success. But today, most volcano launches consider the time to be the coincidence. Since lava flows like a liquid, experts leave the bombs merely displaced is forming a crater revolving lava could then refill. Perhaps more obvious solutions is cool lava with easier. Due to lava low heat conductivity, this requires an enormous amount of H2O. But that didn't stop the Icelandic government in 1873 when the airflow and lava began swimming toward the Himalaya harbor. They began a highly controlled effort to pump 6 million cubic meters of seawater onto the lava flow. That's enough to fill 2,400 Olympic-sized swimming pools. At the peak of their often diminished 6 months long eruption, 75 people work in sheer around the clock, spraying down each activity advances area for nearly a full day to stop its flow. This approach saved the harbor, but it could not only work in a place with access to this much water. Religions further from the coast required different distance and large eating barrier, typically made of material like sand, dirt, or volcano gravel. This barrier can divert lava flow away from population areas. For example, when Italy Mount Etna erupted in 1983, workers used 77 the equivalent 750,000 cubic meters of material equivalent of 225,000 shallows to erect 4 large barriers. The people of Green Davis took a similar approach after the 2023 eruption, building 25-meter high barriers that successfully diverted lava from multiple eruptions. Since the device lava raised the ground level as its flow, this barrier can have to be raised between each eruption. But the advantage of this approach is that it's all to build up the even flow instead of lowering them. Scientists are still working to better predict exactly where lava flow will merge, the direction they'll travel, and just how much lava and erosion will produce. But once they figure it out, engineers can lava reach distances to predict communities from these otherwise approach in spreading erosions.